properties of discrete Fourier transform. So periodicity, linearity, sequence, circular symmetrics of sequence, and symmetry property of sequence, circular convolution, multiplication, time reversal of sequence, circular time shift, circular frequency shift, complex conjugate property, circular correlation, perceivable theorem. So these are the properties of DFT. So x of n, that's a time domain that will be converted to x of k frequency domain, discrete Fourier transform. The periodicity x of n and x of k, so it's a pair. The period sequence x of n can be given as. So this is the periodicity formula. X of n plus capital N is equal to x of n for all n. X of k plus n, x of k for all k. The period sequence x of n can be given as the formula is x p of n summation infinity to minus infinity plus infinity x of n minus 1n. So linearity property. So x1 of n is equal to x1 of n. So that is equal to x1 of k. So both is equal. So and x2 of n, that is x2 of k. If it is x1 of n plus a2 x2 of n, so that is also x capital x1 of n plus a2 x2 capital x2 of n. So here the small n and here the capital X. So it's a linearity. So two or more signals are equal and same linear combination of DFT individual signals and circular symmetry of the sequence. So A said to be clearly even the symmetry. I put the point 0, the circle, thus x n minus 1 is equal to x of n. So similarly, x of n minus 1 is equal to minus x of n. So this is add and this one is even value. So this is add value. And this is for that folded sequence. The value is x of minus n is equal to x of capital N minus n. And symmetry property of the sequence. So symmetry property, the real value x of n and x1 of n, and real and even sequence x of n and x1 of n is equal to 0, x1 of k is 0, so x of k summation of 0 to n minus 1 x of n cos 2 by k by n. So real and add sequence, so this is a value, so sequence real and add x of n minus 1 DFT becomes n minus 1. So x of k minus j, so 0 to n minus 1 x of n sine 2 k divided by n. And circular convolution, so circular convolution x of n that is equal to x capital X of 1 of k. So this is the circular convolution. The circular convolution mentioned the symbol is n the whole bar. So this equation y of m is equal to n is equal to 0 to n minus 1 x of n n2 m minus n capital N. And then multiplication, so basic multiplication x1 of n x2 of n, so that is x1 of k n and the circular of n x2 of k. So the multiplication of two sequence in time domain, the result in circular convolution of the TFT is frequency domain. And time reversal of the sequence, so it's a time reversal. So x of n, that is a frequency domain, x of k, n means time domain, k means frequency domain. So x of n minus capital N minus n, x of minus k whole power n is equal to x of capital N minus k. This means the sequence is circular folded, its DFT also circularly folded. And circular time shift, the circular time shift states that okay, this is the equation x of and x of n minus n. So x of k e power minus j pi by k 1 divided by n. So this is the shifting sequence circularly by one samples is equivalent to multiplying this DFT by e power minus j2 pi k 1 divided by n. And circular frequency shift, so previously we see time shift and this one is frequency shift. So frequency mean it is k. So the thing is previously we have the value, here this is the value we got it. And complex conjugate property, so complex conjugate means a star indicating star. So the imaginary part will be get the change the sign value, this complex conjugate property. And circular correlation, so this is circular correlation equation formula. This means the multiplication of DFT of the one of the sequence conjugate DFT of another sequence is equivalent to the circular cross correlation of this sequence in time domain. And Parseval theorem, so this is Parseval theorem. The formula states that so n is equal to 0 summation of n minus 1 x of n y complex conjugate of n is equal to 1 by n summation of n is equal to 0 to n minus 1 x of k y complex conjugate of k. So this equation give energy of finite duration sequence in the term of frequency component. Okay, thank you.